Hi everyone, welcome back. We continue on this and lastly we learned about this MSCR feature detection, and today we are gonna start a new one which is BRISK, and the plan is gonna be the same for this one also. So we are gonna first of all compare with the previous ones which we already learned, the other feature detections, and also we are gonna make a simple example about the initialization of this BRISK class, and also we are gonna check how it looks like. Okay, and we can first of all compare this with the other ones we already learned, which is KZ, GFTT, AKZ, and MSCR. In here you can stop the video, you can check by one by, but I can tell that in this table, at least for these aspects, I can say that the properties are very similar to the KZ, but only the methods in the behind using is different. For example, this is using a binary descriptor and this is using kind of float point descriptor. So these methods are just different, but of course this is also changing the results. So but before starting, I can say that KZ is really accurate. In some cases we don't really want it to be accurate, but yeah, this is really accurate. Even for many details things you need, KZ is gonna be better than BRISK. But for major things, for major detections, feature detection, maybe it's gonna be better using BRISK for efficiency for other things also. Also, since we are gonna use the same image, for example, for trying our C++ code, so you can go back to the KZ and you can back again here, so you can see the differences, or in your environment you can also check by yourself. Okay, and here I already changed the image. For example, lastly we were using the something like different blobs, but in here, since in KZ also we are using this because there are some corners in here, which is we are calling them also some features. So that's why I back to this image again, and yeah, this was image. So I'm gonna code from the scratch so we can easily follow, and here I'm gonna call just our this BRISK class, and here BRISK we can write, oops, and here we can simply just create it, and yeah, create. Okay, and we can use the use with the default parameters at the beginning, but in the next video we are gonna also focus to the details of these member functions, which are the parameters of the BRISK. Okay, and the next is we are gonna define our things, because first of all we need to compute and detection we are gonna follow. So first of all we need to define, maybe just by, first of all we can call, so what is needed for the compute. Okay, compute, and here is needed descriptors, so it needs descriptors. So first of all we need to detect the descriptors, so BRISK dot detect, and here all we need to do is just giving the input image and the key point vector. So we need to define a vector in here which is gonna including the key points, our key points, and we can call this as key points. So these key points are gonna be the corners, we can say. So these are gonna be our features, but the descriptors means for each detected point there's gonna be a descriptor list. So those list of numbers is gonna represent that feature. So by this information you can also compare the detected feature with each other. So yeah, as we discussed in the KZ also. And here it was expecting image, which is we already defined, and the key points. Okay, and I think that is done. So we already get our key points, and the next is compute, which is okay, what is needed, let's see, image, key points, and the descriptor. So descriptors is gonna be our output, so we can give image, we can give key points, which is in here, and the descriptors is gonna be the array. So let's define it in here as met type descriptors. Okay, so this is gonna be our output in here, and that is all. So this two simple function is gonna doing everything with the default parameters, as I said again. Let's make it clean. Yeah, but first of all maybe we can see how these key points are looks like, and so So we can call the draw keypoints function, which is this one. I want to see in the image, and the keypoints already we get. And the next is I want to see them on the image, and the color is it doesn't really need. Let's see. Okay, let's see how it looks like. Let's make it bigger. Okay, you see, since we didn't define the color, seems it's giving something bigger. And okay, let's define scalar. Oops, let's make add all yellow. Oops, and that is all. Let's see now add all in yellow. Okay, you see now the around the corners you already see yellow circles, which means with the default parameters it's working not really bad, at least we can say. You see, since there is a corner here, there is some circles detected around, so it's giving good results. But if you back and check the Kaze detector video, you are gonna see some detections in here, which is very details. For some people this is noise, but actually since this is in here, so I think it's about the accuracy, about the details. So with the, as you can see in here with the BRISK, you do not see many noises, many not expected, I can say, the detections. Yeah, this is with the default parameters. In the next video we can check the member functions parameters, how they look like, and we can maybe clean, which is most of the cases these unwanted cases, so we can only get the corners. Yeah, but also maybe descriptors we can talk about. So since first of all I want to see how many key points we have, okay, and also maybe we can see how many descriptors we have. First of all this one, and descriptors dot size. Okay, let's see how it looks like. Yeah, now it says you have 168 key points currently, and for each key points you have 64 descriptor number. What it means, if we just write the descriptors at all in one time, so let's see how it looks like. Yeah, you see, for each key detection in here you got 64 descriptor number, which is representing that feature. So by comparing these outputs, maybe you can get a conclusion these two are similar, looks like that. So these two key points are similar to each other. This kind of assumptions you can do at the end. And yeah, for this video simply we just compared and we just make a simple initialization, and in the next video we are gonna focus on to these member functions of this BRISK class. Yeah, I'm done for this video. Thanks for watching. See you in the next videos.